Good morning. Good morning, everybody. Namaskar. This is Engineer Suraj Singh speaking from Bharat, India. This day, 29th September or September 29, 2021, Wednesday. Wednesday, yes. Signals are zero still, I'm not sure. Well, talk as usual. As usual, it is safety, health, environment, and quality. And title is Civil Field Engineering. Start with Civil Field Engineering goes to life, quality AnnexSL, COVID-19, SHE, engineer's role, designs, construction, methods, contracts, organizations, communication, coordination, and why we behind quality of standards, materials, works. Sorry, little cold. Works, materials, and works. I every day try to make this talk for convenience of everyone, and there are so many topics in this, but these topics are all linked. Only for purpose of explanation, I can simply write quality, and then you may not even be clear what quality I am talking, or I will have written SHE and you may not be clear. So therefore, I try to write little descriptive title and cover something of that. I cover engineering, I cover some life, some quality, some safety, some part of COVID, and likewise, I try to respect my title that way. Also, I just like to inform that another topic was numbers, power of soul. Yesterday, on 28th September 2021, I uploaded one file on script.com, SCRIBDT, and that is power of soul. If you are interested, you may refer to that. It's on Facebook, it's on LinkedIn, and also on Twitter. I like to post it on Safi also, but there's some problem with that. Later on, if I like, I will post there. It's just for information. This is quite good. Of course, this is not engineering subject, but this is life subject. It's therefore interesting one. Well, safety is a part of life. SHE, safety, health, environment, which is, you can say, integral part of life at every moment. It doesn't wait for anybody. Safety is required at each and every step in our life. It is required at each and every step in our life, and that is important as well, because it is necessary, and competency says that we have to be careful about this. These are competency references. I'm just trying to show you, and this require that if we are competent, it's our duty to care about safety and care about quality. I don't want to repeat, but just try to initial explanation that safety, health, and environment is a must, and if you don't care for is first and must. I say must because it's not for you alone, it's for others. आप ही के लिए सेफ्टी जरूरी नहीं, औरों के लिए भी जरूरी है. थोड़ा हिंदी में बोल रहा हूँ क्योंकि कुछ लोग माइंड करते हैं आजकल, बहुत बड़े बड़े लोग, कि हमारी भाषा हिंदी, और समझते नहीं कि भाषाएं किसी की नहीं होती. वेल, सेफ्टी, हेल्थ एंड एनवायरनमेंट इज़ वेरी इंपॉर्टेंट टॉपिक. In fact, this is important to a level where you should, means it is your friend everywhere, and also it is your destructor everywhere if you do not consider this. Safety is friend of everybody, and safety does not care what you are, who you are. If you are involved in injury, you may be whoever. You cannot say I am very big, I won't be impacted by safety. Safety is such subject, such you can say action in life. If you are not safe, means you are not safe, and if you are safe, you are safe. You cannot leave it to circumstances. You cannot leave it to know that my God shall take care of mine. God will do its work, don't worry. Don't think that God shall take your care. First, you are your own God and you have to take your own care. That is what God mandates. God has given us mind, God has given us body, and God has given us that try yourself to help yourself first. And if you help yourself, then I am there to help you if you find some problem, because you are also an integral part of God. In fact, it is scientific that without God's blessings we cannot survive. This body itself is blessing of God, otherwise we would not be here. And this body is perfect example of quality system of God. I refer always body, human body or some other body. Body is a perfect machine, and it is such a machine. In fact, it is 24/7, to be very frank. It never stops, while those who write 24/7, they stop sometime. Body is such an efficient machine that it never ends during its entire life. It doesn't require any shutdown maintenance. We always talk of shutdown on facilities and plants, that this is shutdown time, maintenance time, and life is this 30 years and 99.9% it has to work, and this is shutdown. So it is no shutdown. It does not know what is shutdown. It does not know anything. It knows only that when this machine is commissioned, and then when it is demobilized, I can say in engineering language, we were mobilized at time of birth. Everybody is mobilized at time of birth and demobilized at time of leaving this body. You can say birth is mobilization and leaving for heavenly award is demobilization. This period of mobilization and demobilization, we have given our reference name, and that is called life. That is called life. And there is an operation engineering we can call between these two periods, between these two dates, which is, you can say, plant works. A plant works, and that plant is this body, which does not need any fuel from fossils, but it also does not require any electrical supply. It requires only little food for stomach maintenance, and it works then without problems. It has its own software. It doesn't depend on your softwares or electronic software. These softwares are that even you can't write language of this software. There is no machine language for this. It is direct software, indicative scenery software, and we have complete system within which human has not understood clearly, explicitly till now. And there's no one machine. There are billions and billions of such machines working around the world. Every machine has some schedule, some time of start and some time of completion. So I can say that indirectly this is also a contract with God. You go, my dear, you go to earth, do this job and come back. It is employee contract, you can say service contract. Well, I'm just trying to entertain you, don't worry about that. This is engineering operation, my plant, my body. And if you think on this a little, and you can think very well because you are an intelligent person, it's not engineering alone, it's life, and also not life sciences. I'm saying life. Life is higher than life sciences. I'm not talking about life sciences, I'm talking about life. Life, that's I say, engineering is life and life is engineering, that's true. But I am concerned with quality, safety of every material, and body itself is a material. You can say material with you can say it's not simple material, it's working material. It's a machine which has hardware and software both. So if you consider example of this body, you can understand, everybody can understand that we are nowhere when we compare this body system of working to our engineering. I think engineering is very small in that case. Engineering science is at low level, and also medical science is at low level, because how this body works, how does this body work, nobody knows. Secrets nobody knows. Yes, we know by eyes, we know physical presence of universe, we know physical presence of solar system, but we in fact do not know who's operating that. We do not know how it's working. Yes, we can use it, we have used it, we are using it, we shall be using it. You can say all sentences, all tenses I am saying. Earth is moving, earth was moving, earth shall be moving, we can say that. Same way, our machine keeps on working. Some machines work, some machines leave, some machines come. It happens. A small piece comes, it enlarges itself, and then it works and goes away. So that is what body engineering is. So if I compare body engineering to life engineering or to engineering world, there is a lot of understanding that we can learn from our body and universe. We can say our body is a teacher and universe is a teacher. There is no teacher, no professor higher than these. Sun tells us something, stars tell us something, skies tell us something, air tells us something, rain tells us something. They tell something, they give some message without speech. But we do not accept this, we do not recognize this, accept enjoying them. Everybody enjoys rain, everybody enjoys sunlight, some enjoy, some don't, I can't say all. Some enjoy air, some enjoy water, sea, flight, etc., etc. We all enjoy life. But we never think of origin and how could this be done. And until we analyze or even think to analyze on that, we can learn a lot. Safety is one point. You see, we talk of safety on works, but I am talking safety of nature. Nature has given us safety. Safety covers the body. Nature gives us food. You can say we get grains, we eat wet grains and rice, vegetables. We get fruits. You can notice them. You just notice them. Everything is well packed. If you see banana, apple, mango, or whatever fruit you get, this is a kind of complete protective package, for time being, for how many days it can be preserved and then consumed. There's a time that within that period, that product, that fruit shall not decompose. Within that time, it can be consumed. Every product has some arrangement, some definition, or if you preserve in some other place in cold storage or somewhere else, it will also be continuous for preservation, it will live long. Well, that is what I say, safety arrangement has been made there. God knows that this is direct food, there is no process on that. You have not to process on any fruit, and also on you can say crop products, agricultural product. We have to understand lessons from this. God has given us something which we cannot construct. I am sure we understand that we cannot construct human body, and we also cannot construct any other body. We cannot construct banana, fruit, wheat. We have to grow only. God only gave everything duly engineered, which we have to try to understand. Okay, we eat all that, we consume that, we enjoy that, but even then we do not respect that. We allow decompositions, we allow wastage, we allow everything. Why we do not understand safety of that one? My body or your body is free of cost, but it's very reliable, it's functionable. We cannot do any machine, we cannot manufacture any machine that can work without any problems, without any fuel, or without any problem. After all, we are human beings, we are product of that power, and that power can do perfect work. But we still search for perfection, even after claiming that this is expertise product or this is perfect product. So here I can say that we have to be very serious all over the world about safety and about quality. My body, our body, everybody's body is an explicit example of safety standards and quality standards. And moreover, on top of that, COVID-19 has also been a dean, a professor to teach us what we should do. I can say the role of engineers here is very significant because engineers are teachers in society. Not formal teachers, but very important teachers, without whose teachings, society cannot learn. When we develop something, we produce something. When we develop anything, we have to undergo a lot of process, and that process itself is educational syllabus. Maybe it's not for examination, but for life. And it's not essential that we do all according to what we learned in universities. We have to apply common sense also. A part of our job, I think 50% or more than 50%, we apply common sense, and particularly in basic engineerings like electrical, mechanical and civil. Generally people they call in our language jugaad. And jugaad is nothing but a practical engineering without any functional formula, without any derivation. It depends on how can we solve some problem instantly or perfectly, and by application of that many times we can research on that. So what I mean to say is, we cannot simply enjoy something unknown. We are bound to understand safety, and it's not that today it's new, it's very old. It was not formal. Only difference is that now safety, health, environment and quality have become formal subjects. Formal in the sense that when we know something, we systemize that, and one system we think it's produced or it's available, we can say it's a subject or it's something. You may call it subject or discipline or subdiscipline, whatever. So our life is a product of engineering by nature, and we have to maintain it, and nature maintains it in fact. Which maintenance means we have to eat, we have to live, we need energy. In addition to food, we get energies also from nature, solar energies, air energies, skies energies, whatever we have, without which we cannot live. Water is also provided by nature, and we just treat it and drink it. So question is, quality exists since nature began its existence. Quality is already there, but we do not understand that. The sky is full of some unknown. Planets are unknown. We know there are planets, but we do not know thoroughly what they are. And that's where science has been working. It has been working for decades and decades, and maybe it shall work for centuries. I don't know, we won't be here. What I mean to say is, we have to consider very seriously what is life. If you understand life, if you respect life, I think we shall get rid of everything. And I stress always on professionals, on thinkers, on intellectuals, on engineers, on doctors, and all those who can directly impact life, and their assistants, their supports, their administrators, or whosoever executives they are, who have to run those formula, those instructions which are given by engineers and scientists. But it does not happen actually, because of some political reasons or some other reasons all over the world. And that's where clash point appears, because politics and sciences are great distant together. They never meet. Politics is just nothing but abuse of power, while science and engineering are everything, but they are not used. So there is a question of abuse and use. If you don't use something properly, you will get lost, and when you abuse power, you also get lost. Both are bad. Abuse of power means you want to dominate on people, but dominant is not answer. Answer is service. Can we serve? That's the question. For me, politics is service, not dominance. Service means it's not necessary that you should be in a seat of power. You should serve people, that is politics. You should serve them as required. God serves us. God does not demand anything from us. We may pray, we may not pray, that is different. That's another aspect. But life is different. That's why we should respect safety for everybody. My focus is on safety and quality. If we understand these two, I think a lot of problems shall be solved. Maybe we don't find any problem and we could solve it if we understand that. And for that understanding, I always change my contents of talk, but focus remains on safety, health, environment and quality. This talk is also whatever I have written here: civil field engineering, life, quality, AnnexSL, SL, COVID, SHE, engineer's role is all one. Then because the other part is designs, construction, methods, contracts, organizations, communication, coordination, all these also one. Because for purpose of doing something, you require all this. Without designs, we cannot move. Without construction, we cannot. Construction doesn't mean only building construction, but every construction or manufacturing. Construction here is every part. Without designs, we cannot move. Without construction, we cannot do anything. Without methods, we cannot understand anything. Or our understanding is method expression. You can say we express everything on method. Then contracts. Contracts means some way to do something, how you want to do. So that's also a you can say platform. Then organize, how to organize, whether you do on contracts or otherwise, work is to be done. And then you have to communicate with each other. Without that, you cannot explain something. You are not alone in the world. People have to work with you. You have to work with people. And then everything should be done at the same time. So we should not waste material. We should not. That's all coordination. Means many activities run together. They should meet at one point. That's what the focus is. And we just allow these activities to move at one point. It's called coordination, nothing else. So whatever is required, whenever is required, means there are 20 activities. These must meet together at one point, and that's how you can do work. So question is how to establish it and how to control it. Maybe mind understands, if people don't understand, it's difficult to explain to them. Sometimes communication lapses cause problem. Sometimes coordination lapses cause problem, because everybody has its own interests. When reality comes into picture, means we can say, oh no, these people could not understand, I failed to communicate with them, I failed to coordinate with them, I could not explain them in time, and there was there's a lack of information. So what happens? Information comes to play. Information is very important part in life, everywhere. And then we can say, okay, there was no information, something was there, and we have to give this information to everyone. So I'll just close this certificate because I do not give them open for nothing. Okay, so it is now what we say. It says that quality is required everywhere. It's not conclusion, it's just justification of what I'm saying is quality is required everywhere, in every activity in life. So what are activities in life? I think there are unlimited activities in life. Everybody's life activities are different. We have personal activities, we have family activities, social activities, national activities, professional activities. We are bound by innumerable you can say routes for activities, divergence or convergence, whatever you can call it. From individual it goes to world, and from world it comes to individual, both way. That's life. It's practical life, or you can say physical life. It's not. I'm not talking on mind life. Means impact of life on everyone. That impact is very important to understand first, because it affects everything. What we do for people, we do for world. Whatever we do in today's world, I cannot simply say if I do something, it's only for my country or my state. No, it's for entire world. In engineering, it's for entire world. In medical science, it's for entire world. These two domains, engineering and medical science, apply to humanity and not to whatever nation or community. We cannot answer that. It applies to whole world. So when we say engineering science and medical sciences apply to whole world, then our responsibility is focus changes. We cannot simply say I am here to develop my nation. Yes, nations shall be developed, but nations development means world development. When science is developed, science is given to people, everybody in world enjoys. Electrical, we got electricity supply, we enjoy till today, we are enjoying, we can't live without electricity. Same way, whatever service is given by science, everybody enjoys that all over world. So we can say science and engineering are such professions which can't be defined in material terms but in survival terms. Today, without sciences, without medical assistance, we cannot survive. But we can survive differently without presence of whatever system of administration or whatever system of politics. These are secondary requirements. First requirements is survival physically, survival by food, and that science and engineering can serve for us. So we have to respect and evaluate these for human being. Administration can be managed by whatever means. Politics can be managed. That is not first principle requirement. That is only support requirement. When see on projects we say this is lead staff and this is supporting staff. So our lead is science. Whatever sciences we do, sciences means all sciences. We cannot move without that. And these sciences have innumerable subjects like safety, health, environment, and you can say quality systems, mathematics. Mathematics is involved everywhere, otherwise science can't develop. And then you can say medical science degrees and engineering degrees, which are nothing but collection of some knowledge that this level one must get to declare oneself as an engineer or doctor. Designs in engineering are very important parts, and designs means it's work of mind, it's work of, you can say, vision, what we should do or what we have to do, and that's a part of first step in engineering. Then its implementation is another part, and after that its maintenance and operation and use. There are three different, you can say, tracks on which everybody has to go. Designs is complete use of vision and mind and theories, and how it can be implemented, that part must be kept in mind. And if that part is missed, well, I think that design won't work. Then construction comes, which is detailed work, where you can say one person cannot work. Just like in designs, one person may also work, but in construction, it's complete group of people who work, and every group of people and every person in a group is different in efficiency, in mental use, but we have to work together, whatever efficiency one got. And that's where we can say we devise methods. What method we have to do, how we have to do, what is best one. We try one, we do not like it, we try another one. Likewise, many routes can be adopted for doing job, for development. Then we can say somebody has to do it on responsibility, and that responsibility is very much important, because without responsibility doesn't mean you will be penalized. This means you take responsibility and do this. Of course, there are money payments, there are something else considerations, that is different. But point is, somebody has to take responsibility of doing something, and that's called contract. It can be service contract like design contracts, it can be construction contract, it can be supplies contract, it can be whatever else. And then how to organize if there is a contract or if there is no contract. What organization we should have. It's not necessary that we should have contract for every project. We can do ourselves also, those who are involved, but that's also another part of contract, because they have to do some other contract, then supplies contract, material purchasing, this and that, human resources recruitment. So there's a different contract again. Contract doesn't mean a formal document only. This means an understanding between two parties, what it is. So in that case we can say this is just a track, just assume, means you have to understand which stations come on this route of development. Those stations are subjects, those stations are disciplines, those stations are activities, those stations are operations, what we have to do. And safety is an integral one with everyone, and quality is also an integral one with everyone. That we have to understand very clearly. And if we can understand that very clearly, I think we have done half job without any problems. See, what I am saying is based on my understanding of life. I did not learn it in any institution, but in life. I think more than institutions, more than universities, life teaches you. Nature teaches us, people teach us. And that is different teaching, that is not degree teaching. We do not get any degree, but maturity by such supports. Everybody makes a mistake, there's indeed no doubt, and it should be, because mistake doesn't mean fault. This means I could not understand what I had to do. That's called mistake. Mistake means what I had to take, I missed that, that's all. It doesn't mean I can't do right. Yes, I was ill informed, and that could be a reason that I made mistakes. I could not get full communication, that can be a reason. I could not coordinate, that can be a reason. Or there was something required that I could not get, that can be a reason. There can be a number of reasons for mistakes, and mistake cannot be, you can say, condemned. We should not condemn it until it is repeated because of no reason. That is ignorance. If I repeat same mistake many times, then I can blame myself. Okay, I made first time, and after the second time, third time, then I am a fool, or I am ignorant. I don't value what is quality. That's a part of quality. Quality accepts defects, but it also allows remedial actions. And if we don't remedy it, then we do not respect our quality. And same thing applies to safety. If suppose I am injured and again I do same mistake and I am injured, then I can say I am careless. Who are careless? You are also careless if you do that. These points we have to very clearly understand what is life. That's why I say quality required everywhere and in every activity. In life and in engineering. And life is engineering based, which means that engineering is super life like medical. These standard sentences I just for information and for, we call it in Hindi, in Gunavatta har kaam mein avashyak. Quality is essential in every work. Without quality, sab bekar. Sab suraksha bin sab karam bekar. This just, it may be utpadan ho ya udyog ya nirman. SHE required everywhere. Safety, health, environment required everywhere during manufacturing and in construction, and also during use of products. Whereas, so it is a kind of explanation only. You can explain your way. I'm not saying you explain my way. My explanation is simple. It's not very much subjective. It's just to let everybody understand. And that's why I say ask yourself. अपने आप से पूछिए. Ask yourself. Talk yourself to yourself. Self-talking. There is no way out, and without good quality, compliance, applications, good SHE, compliance, applications, nothing can move in right direction. We have to fix ourselves, because we have no right to beat someone else in name of work. We cannot say you have to face this problem because you are working. We cannot say that. We have to solve first problem of everybody. If someone is in problem, we cannot force that person to work. First we have to solve that problem. That we have to take care of safety. That's our basic requirement. And after we take care of safety, and because safety also has some quality system within this, we have to realize that when we talk of quality, it is for every subject. It's for everyone, for everything. Quality requirement. So quality is that it's required everywhere, at every place, in every activity, in job. So safety, health and environment, though it has been very late that this subject was introduced, but it was understood before also, before it's being formally named safety, health and environment, or health, safety, environment. Environment we have spoiled, everybody knows. Health we have to take care, but now if you see people, 80 to 90% people, or at least majority of people, you shall find they are having ill health, particularly those who are not subject to physical activities in life. You can survey, you can investigate. Some problem is faced by everybody, and who are very hard-working people, workers on projects or in construction or elsewhere, You shall also find different kind of sicknesses with them. Different kind of, because they life is very busy, they cannot take very good food, they cannot keep well hydrated, and that also leads to some different kinds of ailments like kidney problem, like stone problem, and many more such problems, and they suffer also. But they cannot afford a luxurious life. Those who can afford luxurious life, they have different type of problems: blood pressure, heart attack, or you can say hypertension, you may say obesity. Likewise, that is too serious, believe me, too serious. It's not easy, and that's the only reason that I always stress in this talk about safety. There is no end to such deliberations. There is no end to quality requirements, and here is quality part that I am interested, and that is, I started with I can say not started with, actually I did it before, but sharing screen I started few months back, because this facility is available with Facebook, and I moved into ISO 9001-2015 AnnexSL explanation, and there are four I devised 4 parts of this. One is RCC building construction, and other one is, you can say, EPC contracts. These will discuss, and then designs and other services will discuss. So I am on RCC building construction template, and I had gone to, so far we have gone to class 1, that is scope. We have gone to class 2, that is normative references, and we have gone to class 3, that is terms and definitions, in which we have gone through so many points so far. I have gone to, we are talking on temporary works. I remember temporary works, permanent works, method statements, standard working designs or details, quality management, etc. We have talked safety, organization documents, we have talked fire prevention, suppressions, we have talked. So we are talking of excavations, then soil testing on site, etc. So let us overlap this and talk about something in there, so that it's not necessary that I take one point. We can consider overlapping of points as well. And we are saying works. Actually, it is work that we talk in quality system as well as safety system. When we talk of some work, it tells us something. We name that work, and we know how it shall be done and what points we have to check on safety and quality. Safety is one discipline which relates to all disciplines. Safety is such a wide subject. One cannot say I know everything. Same way, quality is such a wide subject. One cannot say I know everything. And if somebody says that I know everything, I think I have to, at least, I can't answer to that question. When engineering is so widened, safety widened, quality is widened. Safety is such that everybody is responsible, but in quality we cannot say that everybody is responsible, because quality is a subject. Once you work in quality, this means it is understood that you know a lot about that subject for that application. But in safety, it is common sense that plays a lot role. For example, you know that I will fall from this height, and if I don't use safety measures, certainly I would fall. And we know sun is very hot at this time, 45 degrees. I can't even stand in sun. How can you expect me to work? That's another way. Means it is common sense. If I am thirsty, I am dehydrated, I have to hydrate myself, otherwise I shall not feel well. So that is also common sense. When you feel thirsty, you drink water. Nobody suggests you drink water. When you are hungry, you take food. Nobody suggests you take food, you take yourself. So safety is self-explanatory, depending on instances where you are. Safety means you have to protect yourself, and more than you, nobody else knows how to protect yourself. Yes, there can be methods, there can be equipment you have to use for your safety. These were before also, that some stone shall fall on my head, how to protect. So, there was no helmet at that time, no hard hat. So maybe people use turbans for that, some other type of turban, so that at least that stone should not impact your head. Well, now it is practically developed. We know PPEs are mandatory, and mandatory means I don't care for mandate. First, my mandate is that my body should work with safety, and not only my body but everybody else's body should work safely. That is my fundamental requirement. Why should I subject myself to sickness or illness or accidents or injuries? This means if I cannot take my care, how can I take care of others? If I can take my care, then I have right, I have duty to keep others safe. That is very much requirement. So we say safety is first and safety is must. Quality is a requirement, that is a must and must and must. But that must has been converted to dust and dust and dust, unfortunately. I am not going to criticize anyone for this. I am going to criticize for minds of people, for courage of people, that they cannot speak, and particularly to those professionals who are bound to do this. And those professionals are for development work, I am saying, for social development, for changes. Engineers are change agents. They change everything, and those engineers are blamable for this. We cannot ignore this fact. Openly I am saying, and to all I am saying, in general, a corporate statement is made that it is engineers who are responsible for such worst situation of quality in 2021. It's not only in our country. Our country is leader of bad quality. Many other countries too are leaders of bad quality, for example China, and also some other countries, probably I don't want to name, but there were some countries which were leaders in good quality one time, but they too are having bad quality now, and that is because of commercial interest or because of some other interest. Quality has dropped, and that is point of concern. In our beautiful nation, we name it Bharat, India, quality has not been exercised properly and has not been cared. I still remember when I got engineering diplomas and degrees, there was no subject, there was no stress on quality. We were not taught what does quality mean. I could understand quality in reality only in engineering field. In designs we could not understand any quality, what quality means, but in construction, and that is because I spend my time in my job mostly for overseas countries like Middle East countries, where I could to some extent understand what we have to do, what should be done, what is required, and what is quality, what is safety. Safety also took time to be clearly understood because it developed very gradually, but quality existed before subject of quality. These Annex etc., ISO 97 etc., these are newborn babies. These were, nobody knew those before. I was in Iraq in 1981. I did not know how work was done. How work was done means quality work. Contractor or engineer or organizations had some standards. Established standards means working standards, not documentary interest standards. Documents also came later on, but we used to call something here workmanship, but there everything was systematic. And I was very happy there. Of course, it took time. I was under additional pressure to learn something which we did not know. I still remember those times when I was too young and just 20s. Means in that age you have to learn every subject, every work if not subject. So there I could realize that whatever I did that up till that time, after education, I learned nothing except how to measure, how to calculate. So measurement and calculation was more important than how to achieve quality. Quality is not a word. Quality is not a word, it's a destination. It's permanent destination. It's not even transit. And to establish permanent destination, we have to go through very difficult routes. Just like you construct a house in your lifetime, the house is your destination, and you cannot do in one day. Whole life earnings, whole life savings are spent, and then you say at least I should get a roof on my head. So your destination becomes roof only, not something else, not anything else. And when you get roof, sometimes you say at least I have got something. That roof is a part of quality. That house is also a part of quality. That you upgraded yourself from no shelter to shelter at least. That's what I say. You have to upgrade at every stage. When you don't have food, you require food. That's also one requirement. When you don't have clothes, you require clothes. And when you don't have shelter, you require shelter. These are basic requirements. When you do works, I come back to my topic. When we do works, we classify them into our own convenience, for our convenience, so that we can easily understand them. We can say we have to start some work. For starting that work, we have to make certain arrangements. It may be whatever class of work, it may be small work or big work, it may be a project or it may be some small activity. You have to arrange something, then you have to work on something, and after that you have to produce something, right? You have to arrange something, just like you bring food material, that is an arrangement. Then you start sorting this, it's another arrangement, and then you cook it. That's one more arrangement. That way is project. You have all informations. It may be, suppose I am designing. What I need as an engineer, or without being an engineer, I have to design something. Okay, I am an engineer, that's okay. But I have to arrange something for that design. At least I should have some idea. Idea or some requirement, if not idea. If I have some requirement, that's also an idea. That requirement I have to think on how to move on it. Either I have some sketch, rough sketch, or I have something else descriptive. Then I have to start preparing and working on that. So it is from stage to stage that we have to move. Design or construction or operations. When we think of temporary work, this is we have to start thinking how to reach to that point. How to reach that point. When we reach that point, we have to think of how to prepare for doing something. We have to prepare what to do, what to prepare, how to circulate on this area in best possible manner. Means whatever we do, first of all it should be convenient, it should be easy, it should not be very complicated, and it should be involvement free, injury free, accident free. Means it should be safe and people should not feel undue stressed. They should feel comfortable at working level. Not luxury but working level. They should feel that somebody is there to take their care or they have to take their own care. And then they have to perform work for what this all has been done. So you can say we generally classify whatever activity into three basic functions. One is temporary function, another one is preparatory function, and then is productive function or permanent function. And then also furthermore that how to get out of that or demobilize from that. So that is removal of permanent work, then removal of preparatory work, and then removal of temporary work. So there are two ups and downs. One is up, one is down. But both are there. And that's where we have to understand, because these are required everywhere on every construction project. And these three are very important factors. And these three are very risky factors as well. Particularly in construction of buildings, construction of plants, construction of road work, construction of, there is varying degree of risk, varying degree. But in structures which are heavy structures or which are tall structures, or we can say where activities are many, hundreds activities go on, there are hundreds possibility of violation on safety. That we have to keep in mind. There are possibilities of ignorance of quality, we have to keep in mind. Because there are ignorances, and ignorances are many, even if you list them, it doesn't work. It doesn't work if you only list them. Okay, listing is fine. That's another safety and quality criteria. Or you can say like quality and safety handling. We have to do that. But after all, what is our target? Our target is delivery of that project. Delivery of that project in time, with quality, with safety, and meeting requirements. Every work is detailed. Every work is detailed on papers, and it is given certain requirement in forms of specifications. When we say specification, what does it mean? Is it general or it's particular? Specification itself has some meaning. Even we say general specifications, these are, it doesn't mean that these are general. There is particular requirement for every activity, so we call it general, or we call it, just like on contracts we say general conditions, we can also say general specifications or particular specifications. But specification is specification because we say specific, particular it is. Specialization here is we have to follow for this work this requirement. A specification is nothing more than a requirement. And when we say requirement, or when we say mandate, you can say requirement is not easy. I require this, give me this. Simple. What does it mean? When I deal with someone on an individual basis, I would say, dear, you are there, I am there. I require this and you are able to do this. Tell me, if you can do this, I will pay you this much, or you demand how much you want. That is only, nothing else. Only this simple. I need this requirement, you can do this, give me this delivery and take this money from me. I think this is so simple, right? This is actual contract. When you buy something, you pay some money and get that item, and that's it. This is contract. I give you this money. I have to travel from this station to that station. You get me journey. I get you money. Irrespective of whether money is paid in advance, that's different. But that is contract. It is so simple. There is a track on which we have to move together. Nothing else. Both are in fact agreed contractors. One is called employer in another term, and one is called contractor in one term. I am employing you, so you can say employer, though I am also a contractor. And you are an employee because I am using you and you are giving a service, so you are employee. Means it is something very easy if you clearly understand that. Contractor doesn't mean some bad item or bad thing or bad name. We deal with contracts every day. Everybody is sometimes contractor and sometimes a service provider. It happens. But development is development. Works are works. Civil engineering is full of such works. Mechanical, electrical engineering are full of such works. And all other engineerings are full of such works. But particularly in mechanical world, electrical world, people work in factories, they work in plants. Civil engineering people work in construction. Construction is done everywhere. Of course, volume may differ, quantities may differ, and you can say domains may also differ. But activities are activities. So how to do something is very important point. In civil engineering, in construction engineering, in building engineering, if you check, you shall find long list of activities. Long list of activities. Some activities that are not available there also, which we devise at time of project. Everything is not available in books. If you go through books, you will not find anything. That is related to practical approach. Because books are meant for students and not for professionals. Only professors write those books, or you can say teachers write those books. They are authors and their capacity is to write to only that level which is required by the students of engineering. They do not go beyond that because of commercial reasons. No author publishes practical books. I have experienced that. My point of view was, when I wrote book, that I could not find information myself in my required time. When I was in field, I did not know what I had to do, and nobody was ready to tell me, because I was in that position. I was engineer. Who would tell engineer what to do except engineer can tell, that's it. And if there's one engineer, you will not find another engineer there. And there was no communication to interact with. So I faced this problem in my life. How to handle people when you don't have any information. This is a difficulty. You can no university can teach you practical life. No university. You may be from whatever university. Yes, theory you may learn, subjects you may learn, but there is no subject as such that I am referring to. And that subject is field experience. That subject is design experience. Design is available in theory, but that is theoretical. Practical aspect must be considered, and if some designer does not consider practical aspect, then that designer is not original one. That designer is not coordinating one. That designer is simply a designer, nothing else. And that design would fail always. It depends on experience of designer. If designer has some experience, then designer can understand site problems. But generally, everybody is born designer, because nowadays everybody is an engineer. I am a design engineer, I am a structural engineer. They don't want to come down from that landing. One has to be at bottom first. Otherwise, you may think you are, but in fact your work will tell you are not. There is a difference. I was a designer, I am a designer, but I don't claim that. If required, I can design. Of course, it may take more time, certainly. I am not expert on softwares. I'm not expert on anything, but everybody has some function in life. I feel construction is more important than designs. That is my feeling, analytical feeling, not sentimental feeling. I'm saying I reached a conclusion that designs are done by engineers in details, and these are accurate. There's no doubt. But because designers nowadays use software only, conception misses. Designer must have a conception, and that conception really misses. Designer should think of construct ability, build ability, and then design. But it is not happening. They think design work is a machine, just produce it and give it. I don't think that. I think that design is a work to lead sight. Try reference. I'm not going to show someone I have done this work. You just take these drawings and do. I have to think myself, if I am there on this work in construction, can I conveniently and comfortably and mistakes free do this work on site? That should be my consideration. And if I cannot do that, then I make mistakes, then my conception is not clear. I may be postdoctoral in design, but I am not a real designer. Work speaks in engineering. That is important. If my work cannot be done professionally in an organized way, then there is something wrong with my designs. I have to think. I am not interested in calling myself a structural engineer if my design is not well done. Ultimately, it has to go to some people. Whatever I design, I am just referring only. I am not saying my copies would go there. I should know aspects, practical difficulties that would be faced, and I have to keep myself in that position. I am on site. Maybe I am layman. I don't know anything, because ultimately it is lay people who are not well educated. They we call laymen. They are not laymen. In fact, they know work. They know technique. They produce activities. It's not easy. Form working is not easy. Steel fixing, cutting, etc. are not easy. Same way concreting is not easy. They know techniques, and if they do not know, they are trained. So we cannot call them illiterate. Maybe literature wise they are illiterate, but work wise they are more literate than what I am. Practically speaking, it's a fact that practically they know more than we know, but they may not explain, they may not improve, and we have to learn from them many times. It happens because what they do is to be done. We have to observe that. We have to observe that. We have to observe machines, how machines work. We have to observe how our resources work. Are they working right or not? Because they do not know codes, they do not know sequences, but they work. So we can chart out what they do in a formal way. And if we consider that they are doing right, then we have to give a layout to what they do, give a plan to what they do in our organized manner. Of course, we have training for every act. We have training of construction, we have training of, you can say, designs, but that training is not work oriented. That training is from books only. Writing book, people think you read 4 books and produce 5th one. That is good for text. But as far as practice is concerned, work is concerned, that fact fails. Because first of all, no project is same, no foundations are same, no soil is same, fundamentals are same, but materials are not same, resources are not same, techniques are not same to some extent. This means permanent works will be different everywhere. Different in a sense of hierarchy, because permanent work means preparatory works, and preparatory works means temporary works, and temporary works means mobilization, availability, requirement. Try to understand analysis of this. We say we have to analyze this project. Analyze means we have to do every activity we have to bring to analysis. Every requirement from initial stages we have to analyze, and that is not easy. That is not at all easy. It is cumbersome, and it depends upon experience of professional. It depends upon experience of foreman, engineer. It depends upon experience of people, because when you do all that, we seek some information that we don't have sometimes. Young engineers do not have any information as such, to be very frank. Whatever degrees they have, that is respectable, but a top degree is work orientation. We seek information from our resources. This work, what is way of doing? If we do not know, sometimes we have to either talk to them directly or to talk to them when they work. That's what I said. They cannot express, but we can understand what they are doing. And then we can say, okay, we can measure time in that. This activity takes this much time, and this activity takes this much time. Likewise, you can say time study, machine working study. All that we have to, and from different nationalities, of course. You can say every study is different. We have to prepare schedule of project construction. We have to prepare schedule of designs. We have to prepare schedule for procurement. And likewise, we have to schedule out, we have to chart out every requirement on project. Project is not, you can say if I am MBA, I can handle this. I can PMP, I can handle this. I think that is only, you can say, a kind of, you can say, fiction in your mind. Without training, without knowledge, without experience, we cannot give anything on project. That's only misconception, I can say. Projects are full of engineering sciences, particularly civil engineering projects. If you handle, you can say, you have to handle material. We have to do handling of people, workers, human resources. We have to handle machines. We have to handle market. We have to handle contractors. We have to handle owners. We have to handle state governments or statutory bodies. We have to handle laws. We have to handle codes. We have to handle methods. Likewise, we have to handle so much. Of course, it's a long list, but it's not handled at same time. There are various stages in every project. Every project has some stages, and we have to handle accordingly. Same way as I said, handling. We have to handle permanent works, we have to handle preparatory works, and we have to handle temporary works in both up and down route. But it doesn't happen in one day, in 1 hour. It takes time. So we cannot say that we have to handle everything that way. And for that, we have to use some kind of method. Or you can say, though method remains in our minds, that remains in minds of everybody, because they experience that. When they work on projects, they know everything, what shall happen, but they cannot chart it out. They cannot explain it elaborately, and that explanation is a must for everybody, because we have to move on one road, one track. We cannot construct many tracks for movement. Project means a track of levels, a track of activities, a track of sequences to reach some destination. If we move on different tracks, then we shall not reach anywhere. We shall disappear somewhere on route itself. So to avoid that disappearance, we have to move on agreed route, and we have to reach that destination, and that agreed route has to be worked out. That agreed route has to be worked out, and that is very important point. That is where engineers are required. That is where experience is required. That is where practical approach is required. That's where studies that we work on sites, how we work on sites, what activities, how much high time it takes, where we can use what. All these points are calculated by common sense or through your software, and then we can reach some conclusion that this work can be best done this way. There can be one way, or there can be alternative way, or there can be one more alternative way. Like this I can say, means there are so many ways we can go to, and which is best way we have to follow, and that must be described on something, and that something is very important. That document is very important, because that document can be referred by everyone. That document is a communication message. That document is a coordinated work, and that document includes all information that information is required for that project or for that activity, and we name it construction method statement. So can you define construction method statement? That is definition. That is only definition. Definition doesn't mean that it should be a statement only. It should be an understanding. It should be a format. It should be a format. The major part of format is procedure. Every format has everything. It has resources. It has scope. It has material. It has technology. It has safety. It has quality system, and you can say real procedure. Likewise, and it's also not good if you write very long statement, undue statements, because we have to remember first of all that on site people cannot study a lot, cannot read a lot. It should be bulleted, it should be pointed, point should be clear, it should be understood by all in a precise manner, and it should be to that extent explanatory only that it can be implemented, it can be done. Undue writing is also no good. We can say these are clearly, you can say it should be written inspection status in quality system. Of course safety is there. Safety is full-time supervision, is full-time supervised. There is no way we cannot do it, and everyone. But as far as quality is concerned, that is defined well. We cannot overstress on quality also, because overstress means holding work. We have to make sure which important materials, which important items are to be concerned with. Because if you say some machine is working on excavation, what I do then? Excavation is to be worked out. There is no question of quality. What quality is there? You have to set out, you have to know what level you have to establish and excavate. But there are some items where we have to controls. Controls are in excavation as well. Means proper excavation should be done, over excavation should not be done, and undue excavation should not be done. For example, line is there and I go out of line, there is no meaning, and over excavation is not acceptable. And we have to take care about pipes, about some services there. All these we have to resolve, and if you break that service, it means you don't know how to excavate, you don't know how to work. How service is broken, this means you are not clear about work. That is what quality point is. We have to consider quality factors in every activity. It may be finishing activity or structural activity, whatever activity. That's why I say all these three, temporary works, preparatory works and permanent works, are different domains. Payment is made only for permanent works, but that payment includes all items. This is what we have to understand. And once we clearly mark or we clearly plan in forms of method statement, in forms of work statement, then I think it becomes easy, and it can be, you can say, a reference It can be used as reference on similar works in future or on same project. Means if I know how I have to work this item may be repetitive. That item may be done 50 times, 100 times. So that statement can be little modified or can be used in a standard way. So you can say to that extent that documents become a reference, a kind of temporary code for that work, a kind of reference, a kind of you can say record, or you can say learning, you can say history of that project, and that can be used, that can be referred by everybody who is new. They can know what our standards are, and that is not incorrect. It can be corrected. You can improve that if you find more problems, or you can just write more. So construction method statements, writing, I'm not saying just writing in an intellectual sense, which also includes research. That writing is very significant for purpose of system, for purpose of quality, and for purpose of doing something. If method statement is clear to everybody, this means information is clear to everybody. And information means communication. Information means communication. What organization we have, what we have to do, these materials which are written here, do we have? Of course, without materials you cannot do anything. Without equipment you cannot do anything. And without experienced people we cannot do anything. All these points count in our life. We have to realize this fact. All these points count in life. Construction method statement is a professional document. This is not available in books, and this is not available in market that you can go and buy, because it is real experience by every engineer. Experience means resources based experience. Experience is earned only by resources. How shall our people work? How did they work before? Which machines we used, which materials we used. All these are referred to, and we can know this was done in that project, and we can do it here also. So you can say it's simplification of work and simplification of quality way. I have not seen such system in our country. Of course, there may be some government specifications which I don't regard, because when many people sit, they can decide some good. Everybody is not experienced. Generally, they are not experienced, but they decide. Unfortunately, they are not good people who have experiences in field, and they decide on what a student should learn. That's unfortunate. And it's everywhere that we believe in certificates, we believe in degrees, we do not respect experience. That is drawback in our country. I have not seen this drawback in those countries which have advanced in engineering and sciences. They don't have such problem. Only because we are bureaucratic led people. We believe in bureaucracy, we don't believe in technocracy. So this happens. Remember, bureaucracy does not exist, but technocracy exists. Bureaucracy is just paperwork, just desk work, but technology is not paperwork. It is paperwork as well as it is field work. Without technology, we could not move. Today everybody enjoys mobile, it's because of technology. Today everybody enjoys all facilities, it's because of technology, not because of something else, not because of anything else. So what do we say? We have some designs, working designs. We have some details, and if we don't have, we have to make it. We have to do it. When I want to do something on site, I must have complete information. Otherwise, how can I work? I must get related information, and if I don't have that information in time, there is no way I can do that work according to intended requirement, according to demanded requirement. Who shall give me that? I can't have. Who shall provide me that information? That is point of concern. Who shall provide me that? No one. I have to provide myself. I have to search out. From where? From documents, from information, from project documents, from contract documents. I have to find that information. And if I don't have that information, then I have to require that. Whoever is engineer, whoever is designer, I have to reach him. I have to reach that person practically by communication, by coordination, and to dislocate that information where it is from. And that is what we call it coordination. Coordination is very important part. Working designs, working details are part of coordination, are part of detailing. It's true, every detail cannot be worked out at time of contract, because there are hundreds and hundreds of minor details which actually do not impact on cost, because cost is included but details are not available, and there is no extraordinary normal details. It may not affect cost, and then we have to see that we must have all designs, working designs and working details, shop details, fabrication details. We should have all that, and that is basics, that is a requirement. If you do not do that, you cannot work. And you can say that that is engineering. Engineering out of engineering. You may say different level of engineering. That is implementation engineering, that is working engineering, that is execution engineering, or item engineering. In projects, particularly where services are required, where services dominate, such requirements are highest, not cost-wise, work-wise. If suppose electrical work is to be embedded, wiring is to be embedded, and if we forget and we pour concrete, how shall we solve that? You cannot break concrete. That is the point. Means if we ignore these small items, if we ignore such inserts, it's a big problem. It's same thing as we ignore curing, we cannot solve that concrete. Therefore, standard working designs, standard details, what are required for particular application, particular building, particular project, particular level of slab, particular column, whatever. Here is a question of particularity that must be taken care of, and that's where quality is involved. It's a part of quality. You may not say how's quality. Yes, conversion of drawing into working drawing is quality system, because you have to do it rightly. You have to see scenario, you have to see how to locate that pipe, how to locate that electrical conduit, how to do whatever best way so that this item serves well and this item avoids, you can say, clashes with other items. It's really interesting, it's very important, and it's a part of quality system. It's a part of system that quality must be maintained, and it should be done on a thoughtful basis. Sometimes the designs do not tell what to do, but experienced people know what to do, but they cannot tell everybody, and their thoughts, their decisions are included on that working designs, working drawings, and these are approved and then done. And approved means everybody agrees, contractor, engineer, or other specialists who work on that, they agree on something. That agreement is this one: shop drawing, working drawing. These are parts of contracts, though not at time of execution of contract, but considered part of contract for work. These are only few references I am giving you. We cannot stop here itself. There may be many other. But point is what we want to just understand system, and that's important here. We have to understand system. We have to understand, we have to establish our working. That working is more important. And one work gives rise to another work. That's another point. Just like one sequence gives rise to another one. If we stand at point 1, we can go to point 2. If we stand at point 2, we can go to point 3. It's that serial we have to deal with. Important, it is really important. So what I mean to say is that we go to another level of quality, what work they are doing, if they are working on permanent system, permanent works, because that permanent work shall be inspected by everyone involved in that, discipline wise. It may be civil, electrical, mechanical, or else. All shall inspect work. They shall inspect according to their own statements, according to their own requirements, their own codes, their own standards, and they shall refer to some basic points, and that can be, you can say, what they have to check. Everyone has to decide in that system. If it is quality check, discipline wise, every engineer has to understand, has to define what check should be done, and what ITP should be designed for, what format should be designed for, because our requirement is that work should be done according to contract, according to specifications, according to international requirements. Work should be done, and if we make sure, we have to find least involvement, and you can say maximum achievement. We can say we should not waste undue time just on inspections. If we can assess, it's okay, fine, it is done. That assessment is very much important always. That assessment is very much important always. We have to be clear about that. It's really very important, and we have to be clear about that all time, and we are not to worry in that case. That's what I say. We have to be careful. It's a question of being careful, not otherwise. So we can say there should be standard requirement of two documents. One is called checklist and one is called ITPs, because on major projects everybody is available. First is, it's my work as a contractor or contractor's engineer. It's my job, it's my assignment, and I am not other than contract. I'm not other than project. It's my responsibility. My first job is I have to do right work. I cannot say inspector will check, quality person will check, let him check. I don't care. My work should be checked by me. That is first requirement, because I know I cannot be available all the time there. My foremen are there, my supervisors are there, they work, and I have taught them what to work, or somebody else has taught them. They know what they have to work. I have to make sure that that work has been done according to drawings, according to specifications, and that work should be fine. I can servants that work, and I have to satisfy myself first, and only then I can request others to have a look on that in terms of inspection. And I am sure if I am satisfied as an engineer, everybody else shall be satisfied. Of course, some variations may be there, but in principle, without major problems, that work must pass through. Even they accept responsibility lies with me because I am contractor. I have to understand this point. My responsibility is absolute. It cannot be absolved. I, as a contractor, am paid for that item, and that's why it's my elementary duty, it's my absolute duty to make sure whatever item is done by me or my workers or my company should comply with quality requirements, contract requirements. Quality is not independent of contract. Every contract has defined quality system, and that quality system which is defined, which is confined, which is restricted to some limits, must be adhered to, must be complied with, and that is where we say system works. If something applies here, it's not necessary same may apply on some other project. Quality isn't expanded, it can be upgraded or it can be downgraded also on some economical oriented projects. Then we can go to documents. Safety organization documents, including safety induction, training, upkeep and surveillance. Safety has no limit. Safety cannot be bound. Safety is always expandable. It depends on what is your project. It depends on what type of project it is. It depends on it is ordinary project, it is on ground project, it is high level project, and safety varies accordingly. But sometimes something is very common, and that common is we have to understand how to handle this, how to handle safety. Safety sometimes is understood, oh no problem, we can handle this, there's no problem, and then problem becomes. Even you are on ground, say we are on ground, we deal with machine, for example crane, we deal with crane and there may be some overhead lines, electrical lines, OHT, and we least bother, we don't care. There are regulations, there are something, but ignorance has no answer. And this boom by mistake touches wire, electrical wire. What happens? You know what happens? Explosion, sparking, or accidents. Though work is on ground, but it is very risky. We have to use equipment carefully. Equipment and life, both are expensive. So we cannot simply say that it is easy. It is easy provided we understand it. It is easy provided we have solution for that. Even at high-rise buildings, there is a fall problem, people can fall from there. And we know that, and if we do not take safety measures, certainly we do not do our job. So what I say, safety at induction, when you join some project, that is also a device. This simple plan they teach to everyone in half an hour or 1 hour training, that you are induced to this site nature is this, scope of work is this, and requirements are these, you have to abide by these, and if you don't abide by these, it's violation of safety. And then once you enter, then you will find different type of activities for you, whether you have to work in office or you have to work on site or you work on which project, internally, and accordingly maybe there are variations of safety requirements, so you shall be given some more training. Likewise, throughout project you have to learn induction, training, upkeep, surveillance, fire prevention, suppression, other problems, heat, temperature, wind. All these are required to be clearly understood. And because we forget, it's in the habit of everybody, particularly those workers who work in sun, in open, in all weather conditions, you can't expect them to remember all this. So you can say a refreshing is done. Refreshing is done in terms of toolbox talks or in terms of start card or whatever other way that communication can be done. They should remember again and again that they are on risk job, high risk job. Therefore, it's very important point, maintenance of safety continuously, because we forget. And everybody who works physically on sites, all day working 8 hours a day, 10 hours a day, you can't expect them to remember everything. When we sit in office, we work intellectually, we can forget. How can we say that those cannot forget? These are very, few points I discussed with you regarding activity basis, fire prevention and suppression, which is a very, very critical topic everywhere. This cannot be taken for granted. It cannot be assumed that we will not face it. That is, fictitious idea. We will not face it. You can say that's ignorance. Fire is friend of none. It doesn't take any permission when it enters your building, your area. It's free to enter. It does not need any international visa, and it beats you, impacts on you. Therefore, it's very general everywhere, fire prevention and suppression. If we can prevent it, I think that's best policy, that we can prevent it. If we can't prevent it, that is, I can say we can't protect it ourselves. We can't protect ourselves, and that I can say is bad engineering. Prevention is always better, and we have to think for lives of those people who work on our projects. It's our basic duty to keep them safe. First we have to keep ourselves safe, and when we keep ourselves safe, then we have to keep themselves safe. Rather than putting them or exposing them to accident or fire explosion, it's very important part, because fire knows nothing. It doesn't care for anyone. It's very dangerous, and there are varieties of fire on projects. It may be due to flammable products, it may be due to electrical problem, or it may be due to whatever else. It's only due to carelessness, it's only due to ignorance, and if we care a little, it won't happen. There are so many types of fires, and there are so many types of treatments, handling them, curing or suppression. On projects, we have many fire fighting units, we have fire suppression units, also we have systems like Energen, like FM200, or like suppression of fire by fire pressure, water pressure, pressurized water system. It's called a kind of ring on projects under pressure. Also so many other ways. We are talking here only quality system, so I will not go into that detail. We'll talk them somewhere else. So these points we discussed here are very few. I can just rewind what we discussed, just retry them for just refreshing. We discussed there authority. This is in clause 3 in normative reference terms, clause 3 terms and definitions, and here we say control references are authorities, statutes and laws, contract with honor or FIDIC, Red Book or new engineering contract, as case be, or national standard contract if certainly applicable. Contract documents, honors personnel, engineers personnel, contractors personnel, workforce. Daily progress report on status, memos to contractor, technical clarification, engineering clarification, contractual clarification, subcontractors, nominated contractors, site instruction, engineer's instruction, request for inspection, general items, request for inspection, concrete pours, non-compliance report, material approval request, drawing approval request, subcontractors approval request, temporary works, preparatory works, permanent works, construction method statements, standard working designs or details, quality management statements including checklist and ITPs, safety management documents including safety, induction, training, upkeep and surveillance, fire prevention, suppression. And we go through some other activities we have done before also, and these are we did before here: excavation, soil testing on site, soil improvement, blinding, concrete protection, waterproofing, below ground and above ground, cast in situ concrete, formwork, reinforcement fabrication, reinforcement placement, precast, pre-stressed concrete if included, concrete reinforcement grade, soil backfill, piping, concrete blockworks, roofing, plastering, rendering, flooring, doors, windows, ironmongery, kitchen, wet areas, finishes, special items, testing and commissioning, design, estimated quantities, issued for information drawings, issued for building permit drawings, issued for construction drawings, revised drawings, designs, national annexes, nationally determined parameters, published documents and all other necessary definitions. I think somewhere we were here yesterday, we were talking about this second list, and we talked about backfill, piping, concrete block walls, roofing, etc. We're talking of plastering, etc. We just refresh on that and continue. That's also requirement. We cannot just move off. Means refreshing is an issue here. It's required, and we have to move on that path. We briefly talked about backfill, and backfill, as we already discussed, is very important material from every viewpoint, from site viewpoint, structural viewpoint, quality viewpoint, and of course you can say safety, etc. Backfill, though it is very, people consider it's only backfill, they don't realize its importance. People don't realize in common what is backfill, and I have very bad experience with people. Even some engineers, they do not regard it properly. I still remember that time in, I think it was 1987, I was working on a school construction project in Doha. At that time it was quite expensive project, 14 million reals in Doha, Qatar, and it was a good one for my age persons. I was not very experienced. We used to conduct meetings with consultant, and we had to answer all progress issues, and I was actually learner, means I had good designation there. I was a contractor's agent, but I was a learner also. Fortunately, I was dealing with those people who believed in systems. I was dealing with those British consultants who believe in every profile, who believe in every system they manage or contracts required to manage, and of course they believe in trust, they believe in documents, they believe in writing, they believe in promises, and they believe professionally on sites. You know, many nationalities work. Yeah, I had many nationalities there, And every nationality is different. Particularly if you talk of Middle East, you will find Arabic nationalities everywhere. Arabic, which is their requirement, which is their rights. But those people are not good in understanding system. I mean, so now I can't say, but that time I could not expect them to know about system description or what is required. They were experienced in their own way. Provided you explain them, they can change, they could change. And they could not understand that time from English written documents. Means if you could explain to them, they would do it. There were two instances I remember. It was our General Foreman, experienced one, Palestine, very active. I still remember his dynamism more than our foreman. Very dynamic person he was, hard working. But he always needed information. He never tried to cheat me. Once he knew that I was sincere, I was having good knowledge about technical work, I could understand drawings, I could do all technical activities, and not only technical activities, coordination activities as well. I still a joke, you can say a joke, but it's not a joke, it's a fact. At one location, a column was forgotten. Foundations were done, you can say backfill was done, plinth beams were done. By chance, one column location was missed. When I was checking, at that time I said, where's there? Where's this column? He also could not find that. Oh, he said, I think we have forgotten. Means he was surprised to know how he forgot, and we did not discover it. What should we do? If we tell consultant some problem would come up. I said, no. He said, oh, can I take from here only? Means he wanted to raise that column from that level itself, from plinth level itself. No, it was not possible. You do it from foundation itself. He was concerned. He said, what difference it will make? Mr. Jackie, don't be child. Okay, it's good that we got this mistake at this moment. Now we know there's a mistake. Why to hide? What shall you get by hiding? Only tension? You will think and sleep, I missed that column. You may not sleep for your life. You are not doing a crime. Okay, we missed, that's it. If you made some mistake, you correct it. So we did that column. Okay, let somebody backbite us, they don't know job. But that didn't happen. We said by mistake it happened, overlook. And that problem was resolved. And another instance was, actually there were so many instances. Another instance was, concrete was being delivered by truck right from ready mix. And by chance it happened that manager came, consultant's manager, or you can say resident engineer came. I was just taking entry of one transit mixer into site. As routine, there were so many mixers had to come. And in first when it started, slump was okay. And by chance, we ignored slump of that truck. By chance it happened. He noticed and he held that truck. And said, okay, take slump and see my bad luck. That slump was more than required. And he then said, what's limit? I told him this is limit. So why is that? Okay, reject it. You don't know? You have no experience? Oh my God, I thought only this truck I did not do, and he picked it. You can say sometimes it happens. So he said, okay, I will not approve your CVs, I will not approve your proposal until you prove that you know job. He held up my CV approval. Well, he then demanded that some experienced person should be brought to site. Well, that is game, that's your job. I'm just giving an example how it could happen. Sometimes time doesn't favor you, but you by chance it happened. I checked every truck, but that truck was he didn't raise a big question, but still you are not taking care, or you're not experienced. So he blamed on me. Means I was less qualified than what is expected. And also it happened in one case about backfill, which point I'm discussing now. People don't listen sometimes. It happens on sites. Multinationals, language problem, many other problems, and on a big project you can't be available all time at one place. And they fill, I think, about 70 or 60 centimeters. You can say 3 or 4 layers place, they fill, just dumping material on that. No layers filling was done in certain local portion, other was done. So question was raised in meeting. Yes, there's a quality problem. There has been a quality problem. One was that slump and other one is this backfill issue. These people just backfilled so much deep. And this point was very seriously, it's taken very seriously. And there is question what to do. Well, I had no answer. Only answer is the jokes, that president is joke. Can you bring Traxler machine here? Traxler machine. Well, it's very, you can't get Traxler machine on project because it's always on railway track. How can you bring it there? Because Traxler machine is a capacity is go down even meter and compact that. So I kept silent what to do. There's no answer to that. So it was agreed that you will take out all soil, backfilled, and do it again in layers and test it. Okay? How can you say no? It's a question of quality system. Means you have to pass through such problems in field. Only then we can realize. Here I find people, those who do not know anything about engineering, they will say, I'll fill this 1 meter and pour and leave pipe here for watering. They think that it's done. According to them, it's done. They do not understand what is layer, what is thickness of layer, what's purpose of that. Even if you explain to them, they will twist their nose. Oh, because you are from that country, you are talking this, you are not practical. Then you are not practical. Or really surprising. Well, I have many instances as such. I can explain them, but my talk is limited to quality system here. I just tried to get you the soil backfill example, which is in fact very common. It's well misplaced everywhere. People do not take it very seriously, though it's very serious issue. You must have seen news, you must have heard that road settled, there was a pit in road. It's all because of such problems. Backfilling is not taken very seriously in our country. Compaction of formation level is not taken very seriously. And in fact, quality is not taken very seriously. You can take example of rusted steel bars which are used all over and nobody questions it. You think there are no engineers? There are engineers on every project, but that is only for sake of formality. In work, engineering is not employed. Openly, rusted steel is being used on every project and nobody minds it. So what to do? One can speak only, one cannot solve problem. Unfortunately, we have a sleeping engineering community. They are community of engineers, but they are sleeping. So here I say backfill. I have seen backfill on many layers in many meters depths on heavy projects, heavy foundations, because of heavy weight of industrial units, and then settlements become an issue for future. Though it may be desert, there is a structure, there's, you can say, within that limit there is borehole reports, and we prepare site by sand fills or whatever else fill. We raise levels, and generally that fill is not clay, that fill is desert fill or graded fill. And if you improve soil, improve something, we will get compacted thickness, density we will get, and because it is graded material, granular material, we cannot wait for compaction and consolidation together. Compaction is enough, and it works if it is good one, well designed and compacted. Chances of consolidations are remote. So what we do, backfill is very difficult job, though it's not concrete work, but concrete work shall be done on this. But backfill itself is a structure of material formulation in the soil. I'm not talking about steel and something in that, because backfill itself is fill up, and as much as compacted and consolidated, it will be better. So backfill is such an activity which cannot be taken for granted, which has to be complied with specifications, because in many cases backfill is done below foundations due to whatever reason, and if that backfill is not successful, then your foundation will settle. There will be unequal settlement. So we cannot take backfill for granted. Backfill should not be done in clay or silt, but in granular materials. You can say, like we do water-bound macadam, you can use that surface. So backfill can be classified into that item, which is very important but not cared for. But it's very important from technical viewpoint, from engineering viewpoint. Backfill has many problems. It's not simply that we have to compact it in every layer. There are corners, there are edges where compaction is not easy, where access is not easy. You have to keep that also in mind. We cannot backfill blindly. We have to sort out site first. We have to do everything for that. We have to take out all undue stones, undue size of materials. We have to take out from that, and we have to then make sure that this formation can be used for backfill, or we have to do some other treatment. Then our compaction should be well done, due moist percentages, this is moisture content, and we have to compact it so that we get field dry density of whatever designation, 98%, 95%, 90%, depending on type of backfill. When backfill is used for structures, it can never be below 98% proctor density, and it is to be achieved if you want stability of structure. Backfill is done in many places where corners we can use jumper, or so that even corners are backfilled properly, we cannot leave it. Also, it may be pipeline where different requirement exists, particularly below floors 98%, and we have to fill sand around in form of backfills, or concrete and casing, it can be done. There are different requirements. In general fill we can keep even sometimes 90%. In some other fill between structure and such 95%, there can be 98%, there can be 90%, there is 95%. It depends on requirement. But remember, stability is a must. No stability means problems. So backfill has no answer. It is to be done. It won't give you money, but it will give you stability, good structure, and it's the quality of backfill that we have to care about. If there may be any number of layers, when you do mass excavation of some area for ease of working, then you have to backfill also that. But it's very difficult for every engineer to understand what this backfill means, because it's confusing one. Some sites are reclaimed, some are original. Those which are original are having natural consolidation, and we should not say, you can say, destroy that within months. You cannot destroy that. Backfill is that very important. You have to consider it that way. It impacts your structure, it impacts stability, it impacts everything. And of course, flow of water. If water table is high, that is affected, very much affected. We should care about that. Graded fill, cohesive fill, interlock fill, all are different. We should not allow flow of water. We should pass around and below our fill, and pass only when this permeability is high, there is no porosity, water keeps on flowing. We have to keep in mind that water particles when flow should not contain soil particles. That point we have to keep in mind, because you can say when you excavate, pressure of work is removed, and there can be increase in flow of water below backfill. That population or permeability can cause problems in other buildings. It can take out soil particles from there and deposit on our foundation, which it doesn't work. There should be some means for that, and that meaning should be designed. And backfill itself requires to be designed in a proper perspective. It's a very important item, as I said again. We cannot run away from this. And also piping, which has bedding, underground it is, bedding or encasing or fill, or there is no concrete below, maybe direct sand fill, depends upon what pipe is this. So piping are very enormous, very complicated. It can be in project pipe, it can be communication pipe, it can be gas conveyance pipes, and running thousands of kilometers on some project from one place to other one. So that is complete technology of piping project, and that all must be well studied. There are some types of cast pipes, steel pipes, concrete pipes, GRE pipes, for which there is a separate description, separate requirement, but quality still stays there. We have to be very concerned about such issues, and these issues cannot be taken for granted, that we have done it or not done it. We have to be very serious about that. Then we have to go to concrete block walls. Piping is very big, very voluminous work, but our point of view is that quality is important. I'm not going to explain methods in this case. It's quality criteria. And to keep in mind quality system of pipe material, its gradients if required of laying, and functioning of this piping in future when work is done or when we are out of that room and commissioning is required. That point imports requirement about good functioning of quality system in piping, thickness of pipe, dia of pipe, gradient of pipe, what is the requirement of pipe, does it comply with that? All that must be considered. How to join the pipes, means it is gas flow pipe or condensate flow pipe or water flow or some other flow, that must be understood well. Now we'll go to concrete block walls. I tried to explain yesterday also that it's different work. We have to take care of that also. You have to give me a few moments. I'll come back. Just a minute, please. Sorry gentlemen, little delay. I'm back to you again, trying to explain to you about concrete block walls. We discussed before also that what care we have to take about concrete blocks. We talked of projected area, we talked of sizes, and we talked of what is meaning of strength of block. We talked of at length. I think you remember that it is not grade of concrete. When we discuss notation of blocks, we talk of strengths of projected area. It may be solid block or it may be hollow block. We don't refer to concrete grade. Generally is 50% cavity. Generally it's not exact, and we have to take care of connections of block. Have to do block work in some details. We have to connect to structure, we have to connect, and we have to leave some space between top block and beam or slab, some space for expansion, and we have to construct cavity walls also, in which two skins are used. One is external, one is internal. One is 1 block thick, other one is half block thick, and one void or cavity is capped in 100 mm or 50 mm depending on design, in which expanded polystyrene is inserted in that void, and walls are connected, internal skin wall and external skin wall. These are connected by wall ties, of course with little slope, and also these wall ties are embedded in mortar. Of course, maybe in third or fourth course we insert these types of wall ties, horizontal spaced and vertical spaced, and also at ends of walls where columns and walls are connected, we have to use wall ties, not cavity ties. Wall ties are short fired into column surface, into column, and one end is embedded in mortar. So there are two connections. One is horizontal connection, that is between two cavity walls, cavity skins, and another connection is between wall and column. These ties are very important for purpose of connection, and these keep them safe during any movement, horizontal movement or vibration. Then there is a where wall meets soffit of beam or soffit of slab, we keep some gap, maybe 20 mm, and gap is filled with flexile sheet or some other material that is expandable, compressible, so that if there is vertical movement of wall, it should not strike slab. This is general structure of wall. And if we have block wall internally, even we can say if it's longer one, we have to provide some bonding column in between or bonding beams in between if height is high, if height is more than normal. So we can say bonding beams and bonding columns are provided for purpose of giving stability to wall. If it's longer, if it's normal, no need. These are very important points in block wall, or even in you can say block wall or brick wall. Here we do nothing in brick wall, unfortunate it is, and we just produce wall on just by mortar connection between column and wall. People do not care for joints, particularly where there is false ceiling in walls, I mean in areas, covered areas, you may say there is planum, false ceiling level and height above that level of wall is not too much. It's not necessary in that case that we take that wall up to bottom of beam until or provided it is external one. If it's external wall, periphery wall, then we have to take to height. This is normal working of block wall or bricks, and these are not considered structural walls. These are considered ordinary walls, non-load bearing walls, and there are two ways that we have to fill some voids putting steel in, and we have to put some steel in horizontal positions also. In certain courses, 4th or 5th, 8 mm diameter steel is put in horizontal courses at certain spacing, and also vertical columns are, or you can say steel is fixed. If we are not going to give any bonding columns, these voids can be filled with ordinary concrete after steel is placed in, and that is normal specification everywhere. So we have to understand this point, have to specify this, and generally such specifications are available in normally every country's national specs, and it's not available, no problem, we can write ourselves, and this is called concrete block walls. This can be skin wall, this can be cavity wall, this can be partition wall, this can be external wall, this can be parapet. Generally parapet is also done by RCC in such cases because of many reasons. So concrete block wall is this, and it's done at every level, whatever height of building is. It's also done in boundary walls, compound walls, of course with columns in at some spacings for stability, and block wall is done, and it's done on beams or directly from foundation, whatever we lay. So it's also very important to make sure that whatever block we use should be right one. For blocks that are done in soil, in foundations, those are always solid, whereas when we say hollow blocks, these are done in ordinary walls above ground. This is a very important point, and strength of block is very important. We cannot leave it to circumstances. Proper curing should be done, and samples of blocks must be tested to make sure projected strength of block. That is very normal. Means there is no very explanatory deliberation we can do on this, because this is normally known to everybody, every mason, every foreman, everyone knows about block work. Block work is easy to understand, but while doing it, it should be properly done. Main problem comes in when apply mortar on horizontal course and vertical course. It should be completely done, but point should not be forgotten that it is going to be rendered hot plastered, and that's a very important point we miss everywhere, even in brickwork. We don't think of that, and nobody points out that we are responsible, we have to be accountable for racking of joints. Once mortar is done, block layers are laid, cleaning is done, everything is done. Before that, we have to provide some bead impression on all joints on vertical surface. Vertical surface of block work. Vertically as well as horizontally, there are joints. Horizontal joints continuous, and bead can take that. Horizontal joints is continuous in all courses. But vertical joints are because of plumb, these are staggered. Maybe we have small length of bead, say equal to depth of block, and we can use that for causing impression, or we can roughen it by some other means so that insertion bonding is permitted, and that is for plastering mortar or rendering mortar. There should be a connection, a bonding, interlocking between plaster surface and joint. Plaster material must go within that joint, beaded joint or pointed joint, so that interbonding, interconnection stays there permanently, and there shall be no peeling off of plaster in that case. But this is not done by people. I have seen very rare people know it, and they do it, they enjoy it if they do it, and if you don't do it, they suffer in plastering. We'll come to plastering. Roofing we already discussed, and I repeat that roofing, which is already very specific item, particularly for low rise and major areas, plotted houses, where horizontal area is more, coverage is more than vertical movement. Maybe 2-story building, 2.5-story building, 3-story building. I don't think more than that it's important, because if you go up, if you move higher, then it is top slab only that requires roof. But in 2.5-story there may be two requirements, maybe lower terrace and higher terrace, or one terrace depending on. And that roofing is very important item because of storm water drainage. All storm water in that roof, on that roof, falls on that terrace, and that terrace has to dispose of that water in form of storm water, and it should go out down. It should not stay on roof. And if it stays on roof, that's a problematic. Means we should provide roofing system for continuous disposal of that water. And that roofing system I explained already, but I refresh. It's very significant, very very significant. It cannot just be taken for ignorance or for granted. It has to be valued properly. Though our surface of slab is horizontal, it's flat, it does not have any provision of gradient or flow of water. So we have to know what gradient is required, and this is quite considerable. Because of requirement, we have to use it for drainage of water by gravity flow, not by mechanical flow. So this gradient could be from 1.25% to 1.5% or more, depending on what sort of roof we have. Horizontal surface cannot be used for that purpose, so we have to create some grading surface. It can be by use of, previously it was done by using mortar, cement mortar fill. It was done that, but that's not very light. It was quite heavy. The ratio was 1:6 only, 1 cement and 6 sand. And that profile portion, which I am saying gradient or roof profile, we cause first that profile and then fill that profile either by cement mortar or by foam concrete, which is much more lighter in density than cement mortar. 400, 500, 600 kilogram per cubic meter, 700 kilogram per cubic meter, lightweight foam concrete we call it. And if it's available, then we should use that for roofing. But we have to keep in mind that wherever we do, that roof should be clear first. We should have all plinths constructed for purpose of equipment or tanks, water tank or other tank. Whatever services are required on top, that must be taken care of first, must be built if civil work is required there, and then you can say chipping can be done, hacking can be done for whatever portion is left. Not very heavy hacking, but light hacking so that expose the aggregate. When aggregates in concrete are exposed, and then base can be constructed after cleaning everything. Base keeping in view slope up to drain, slope down from every corner, every edge to that drain. That slope is very must. If it's graded one, it shall help us, and we have to either do cement mortar in base or we have to do foam concrete in base. This foam concrete shall not be delivered by ready-mix plant, but we have to mix it on site. Some specialist contractor for foam concrete is hired, and that contractor, subcontractor, vendor mixes on site and lays it. And we don't have much time after doing foam concrete and slope, but immediately cover that by system. Once we do the way how this must be parapet must have been done, we must have all drainage system, everything, and if that is done, concrete is done, foam concrete, then we have to clean everything and we have to make that foam concrete area ready for application of waterproofing, whatever system is approved. It may be cold application, it may be hot application, it may be sheet membrane, or it may be chemical application. Whatever is approved or whatever we intend after approval, either we have to discuss with someone of client or we have to do ourselves. Means whatever is agreed on contract, that membrane or cold application must be applied, must be done, carried out according to specifications, because that's a question of warranty item. Waterproofing system is warranted for at least 10 years. That point must be kept in mind. It doesn't mean that it is for 10 years we are free. That is warranty. But it should be done best so that that stage of warranty should not come in our way, because if it is to be removed and done again, it's big headache for owner also. So that's the only remotest chance that we have to remove that. First is that it should be done excellently on job, not only horizontal surface but also you can say at joints, at slab and parapet joints or whatever joints are there coming in. It should be raised and inserted into chases, and once waterproofing layer is applied, fixed, it should be water tested, leak tested, for which we have to close all drainage points, we have to clean everything, and layer has been set, must be set. Then we have to provide water fill, say up to 25 to 40 mm, maybe for 3 or 4 days. Once it is done, chlorate, your water shall stagnate in varying thickness, but highest point of profile should have at least 25 mm water, so that lowest point shall have more and more depth, and leakage should be observed after 72 hours. Generally, very few leakages are observed, but test is passed, and once it is passed, then you can say answer comes from there to whosoever. But point here is, in remote cases this is okay, but this is okay in live cases. After that, once your water test is over, we have to put, if required, geotextile on that, and we have to cover that layer immediately with our, you can say, polystyrene, extruded polystyrene. Extruded means heavy duty polystyrene. We had Roofmate, one company. There are so many companies. I'm just giving an example. These these square pieces, 60 600 by 600, are delivered maybe 50 thick or less or more, because heavy duty means roof, and these are fixed on all areas, covering, touching all walls, roof walls, and covering all angles, etc. And test after test, this is done. Polystyrene cannot stay there on its own, so it must be covered with say geotest, or it should be covered with your concrete paving stones, concrete paving tiles, or sometimes these are called flag poles. When length is more than width, that can also be done. And these should rest on basis, plastic basis, plastic small circular basis, so that it's well leveled in profile. And joints are sealed. Joints between flagstones are sealed by mastic. There is a provision if it's accessible areas like this, and if there's accessible area different way, then that is to be a different way. But that stage hasn't come yet. So we can say roofing is like this. We have to open all our rainwater outlets, and all our joints means joints between at parapet and this roofing system must be provided with flashing, aluminum flashing. When joint vertical and horizontal is chased, it should be sealed and aluminum flashing provided. So if water strikes or heat strikes that shield, the parapet metallic shield, it doesn't harm anything. So my submission is, once you finish your flashing, aluminum flashing, you can say, and seal, you can say that roof is ready, system is ready for use. This is for roofing, and you must know that we provided plinths before starting anything, on which AC machines or water tanks can be mounted, that is roofing. And we come to important item, that is plastering and rendering. Though it is very important item for me, maybe it's not for you, because it's talking of plaster, but that's also very important item. Generally defects are observed in plaster everywhere, in rendering or plaster. These two terms I am using. Plaster is for internal surfaces, and rendering is generally used for exposed surfaces, exposed to weather. This is only difference. We have to underline this difference in our minds, and we have to make sure that this is done, this is understood clearly. It's all part of engineering and nothing else. Plaster, rendering are important items when material is not surfaced, material is not to be exposed. We have to depend on plastering and decoration. Plaster means what? This means to prepare a surface where bricks or blocks are not seen. Only concealed surface of structure and real surface of finishes is visible. That's meaning of plaster or rendering. To cover all defects or whatever undueness or roughness, or you can say it may also help that less moisture passes through plaster to block wall or brick wall. That could be one more reason. You can say it's a protection of heat transfer to wall or water transfer to wall, moisture transfer to wall. This can be that one. And that's a fact. That's a fact. But why and how to do it? Reason is why it is this reason: protection of water penetration, protection from water penetration from air to wall. Generally people use air conditioning everywhere, but I am not stressing on that. When I collect information, I will discuss with you. Plaster is very significant activity for finishes, because plaster first of all conceals defects and roughness of surface of blockwork or brickwork, and also it provides a base for application of paints, because paints are also very expensive, and also it provides resistance to temperature, resistance to water penetration into wall, some resistance to temperature, not all resistance. So what we think of plaster then? It's not job of mason alone, that is application job, but it's a job of thinking too. Generally we don't take this item seriously and leave it to artisans or plasterers. Now what I could understand, I could learn in my field about plaster, that it's very critical item. It has to take its own care. Means it should have proper grid of beads around. Grid of beads around. And beads means what? Beads is a kind of section in length. It can be stop bead, it can be corner bead, it can be angle, it can be, you can say, junction mesh, it can be made of lath. There are so many names for it and so many sections for it. We have to work on beads first. Work on beads first on clean surface. Not easy. We have to fix bead where two different surfaces meet. It's called generally lat, L-A-T-H. We have to provide corners with bead, corner bead, for example edges of columns. We have to provide that bead, angle bead, and just like we have to provide junction of different surfaces with lat or with mesh. Likewise we have to provide top bead, and we have to provide at plinth level wherever it suits, or if there is continuation, then we have to think for a different way. We cannot take it just that we have to plaster the surface as we do here. We don't care for beads, we just do it. This is different one, means layman plaster it is. But when we say we have to provide network of beading on surface first and then do plaster, this means first racking is done, then you can see beading is done in a profile. You may say profile means vertical profile of surface of material that is to be done. It should be vertical and plumb, no undulations. We should provide a base of that, and we have to break continuity. In fact, we have to break, we have to do continuous plaster, but below plaster surface we have broken continuity by lat, by mesh, by corner beads, by top beads. Likewise, you can say plaster is indirectly for purpose of continuation, for purpose of not strength but just for purpose of some measures that may be affected by weather implication. We have to provide this network, so you can say these are nailed in meshes, angle bead, corner bead, or whatever specific item. We have to cut and fix on site, and we have to fix nails continuously, nails on these walls or different junctions. It's not very difficult, though it's time consuming, but a professional profile is achieved, and once that profile is ready in all respects, means we have checked, means vertical plumb, horizontal lines according to thickness of plaster, according to thickness of first coat, second coat, or we call undercoat, or finishing coat, or top coat, whatever you call it. Thickness of plaster maybe 18 mm, maybe 12 mm, or whatever. This is actually some different kind of work. It's done externally as well as internally, and these beads help in some expansion problems. We have to take measures that we do not want to see cracks in plaster or render. But if you go to see any building, go to see here, you will find all buildings plasters peeling off or cracked, and this to be done again and again after a couple of years, and which is also very expensive. This point we have to keep in our consideration, keep in our understanding how to avoid it. Here we don't do that, but in Gulf countries I have seen, I have experienced, I have done blasting and rending with, we call expanded beads, expanded material bead. Expanded material bead we used, it may be galvanized iron, it may be stainless steel, depending on requirement, and network is formed before doing anything. And what network is formed, we make sure that it's all right. Then we start doing, sprinkling coat or splash coat, then another coat, and then another coat, and all beads are embedded, like embedded, though not embedded exactly, but surface of bead is visible, but in same line as plaster. So it helps, first of all, joint discontinuity, corner seen, lat is embedded in plaster, and whatever is there with corner bead mesh, that is also embedded somewhere in plaster. Then we continuously do plaster work without any difficulty, because there is temperature of 40 degrees, 45 degrees and high. We have to do in initial stages, the curing is a must. That's also missed by people. They are not serious about that to a level it should be, and that point is a big concern. In our country, nobody bothers about such beads, and in case they don't bother about beads, at least joint should be racked, or some bead be left in plaster surface, at least at joints of dissimilar materials like block work and concrete, or brickwork and concrete. That too is, some do it, some people do it, some people don't do it. There is no question of saying, means we have to think of seriously all stages in construction, and that should happen. It should happen. We cannot blindly move on activities we should not do. because we have to apply good paint on that, expensive paint on this system. Somewhere it is polyurethane paint, somewhere plastic paint, somewhere some other paint. Means those paints must be durable on the surfaces. Those paint should not come out immediately by cracks, or these may not work function properly in future. That point we have to keep in mind while we plan for plasters or rendering. Plaster rendering can be done easily, finished easily, but its repair is very difficult because of you have to remove and do again. So it is better from quality viewpoint that we have to plan it seriously, accordingly, or else problems will never run away. These problems continue, stay with us. We have to keep that point in our mind. And give me a few moments, I'll be back. Just 2 minutes. I open my lock and come back. That point is very, very important from every consideration. So we have to be very serious about this issue because this is finishing issue. It cannot be taken for granted. It's very serious issue, and because of finishes, we have to depend on very expensive item of paints and maintenance also. And it gives beauty to building. And if we don't do this or experiment, then we have to provide beads, we have to provide job, you can say plaster gaps. That's not easy as well. So plastering and rendering are very specific items. If you refer to method statements, every method statement is written. I have already put on postings and we'll discuss them again, because we cannot leave for granted anything when you do professional work. It's professional item and must be done accordingly. It cannot be taken for granted. Similarly, plaster is very expensive item because of paints. Then is flooring. And flooring is something is not common for every area. Flooring is something that is very expensive also, depending on what type of floor it is. From cement, ordinary floor, or you can say very ordinary floor, to marble chips floor, to tiling, ceramic tiling or other tiling, mosaic tiling, and to epoxy floor, or whatever floor we do. Every floor is different in specifications, in thickness. We have different types of floors for chemical areas, for offices, for residential areas. Likewise, we have various types of finishes activities. We have to be very sure about floor profile and junctions of different floors, because floor is not common for all areas. Different junctions are available. In one room to other room can be different flooring, so different junctions at threshold of that joint. Everywhere cannot be sill. Somewhere we have continuation of floors. Those joints must be well understood. Somewhere there's heavy duty floors like epoxy floors, warehouse, stores, electrical area, battery area. Somewhere there are decoration floors like marble stones, designs in marbles. It may be granite. It flow to drain or nanny trap, or we can call it flow drain, flow trap. Slope is not that dominant factor, but level is important. We cannot move without that. That's also a very important point in flooring, and that should not be taken for granted. Floors are important in finishing items. These are important everywhere. We cannot move without that importance. These are attractive. Even if these are for residential use or whatever use, there can be heavy duty floors for trucks, generally pavings, or epoxy floors in workshops, in factories. All those classes of floors are different. There should be proper base for them. There should be proper structure if required. Maybe sometimes finishes are not that much, but below concrete is good. There can be floors on railway platforms. There can be floors elsewhere. There can be floors in heavy duty, light duty everywhere we have to treat them. And because we are dealing with floors, then we have to deal with doors, windows also. Doors are important perfectly because doors means to be installed on floors linked to structures below floors. It may be covered area in every room or elsewhere. Floors are related to windows, doors. And if there's curtain walling, then also there's some contact, there's some coordination, some requirements. And we have to, when we deal with doors, we have to deal with ironmongery as well, which are fittings of doors. So we can say we have to study about kitchens, then wet areas, then certain finishes, special items. All these we have to take into our consideration in coming times. It's already more than about 3 hours, and I think it was success to move today also for some concrete discussion on buildings and structures, safety, quality. We are talking is quality and AnnexSL, and that is contracting. I'm stressing more on this because this is very important part where quality can be achieved. It's very significant for. I'm trying to spend more time on contracting because it's contractor ultimately who can deliver quality. Quality can come only from all through this source. Otherwise, you can't even understand what is quality. If contractor likes, if contractors, engineers likes or prefers, quality can be achieved at whatever cost, struggling cost I can say. Struggle is required with everybody to achieve quality because quality has been taken very lightly, not earnestly, not honestly. And I am really upset with those responsible for this. All engineers are responsible for this, but I don't find any degree of seriousness among engineering community, and that's why quality failed. Quality can never fail if we do not fail ourselves. Quality's failure means our failure, engineering failure. If being if engineers are there on job and quality is not attained, I think I don't have any answer to that. That answer is not available. We have to be very serious about that. That point must be made very clearly understood, and we have to think of that seriously. That point is that this one. So we have to be very serious in this issue of quality. There is no joke as such. It should be well done, well believed in, and must be strongly inbuilt. That system. That system is very, very easy. It can be achieved easily if we wish, and if we don't wish, there is no answer to that. There is no answer to something else. And that's why I always stress on this issue that must be achieved, as I said. Design and prosecution works, applications must be affected, and that is engineering plus on both ends of engineering term. Non-conformance product is called substandard, therefore rejected. Non-conformance means engineer is either careless or ignorant or incompetent one, and therefore is a redundant personnel. Quality requirements checks being a must, missing which we have to blame ourselves for quality achievement failure. Engineering means quality application and continuous improvement of quality on quality. No way exists not to comply with defined or specified quality labels, because definition of quality is a must, and that definition requires to be achieved, or else work leads to status of being unsuccessful and to be reperformed. Engineers are problem solvers, and engineers are developers, and engineers are agents of change. Engineer can convert a forest or a desert to a city or an industrial town, for which quality and safety, health and environment play integrated and much vital roles in all respect. This is message for every talk we have to go through, and this message is very useful, very important for everyone to remember. And with this I take your leave. We'll talk again. Thank you very much.